we have the function f of x equals x cubed minus 1. We want to find f inverse, and then after we've found f inverse, we want to verify that we have found the inverse function. So let's first of all find f inverse. If y is equal to x cubed minus 1, to find the inverse, we're going to switch the x and y. And so that means x plus 1 is equal to y cubed. So y is the cube root of x plus 1. And that's what our f inverse is. F inverse is equal to the cube root of x plus 1. Next, we want to verify that we have really found the inverse. And so this is what's true if you actually have an inverse function. If you find the composition of f with f inverse, it will equal x. And if you find the composition of f inverse of f of x, it will equal x. And actually, when two functions are inverses, it has to work both ways. F of f inverse of x is x, and f inverse of f of x is x, because what you're essentially saying is that performing this function followed by its inverse undoes what the other function just did, and you end up back where you started. So let's use function composition to prove that we really found f inverse. If we find f of f inverse of x, then that means that we're going to find f of the cube root of x plus 1, which means we're going to substitute the cube root of x plus 1 in for x in f's equation. So that means that we're going to have the cube root of x plus 1 cubed minus 1. So the cube root of x plus 1 cubed is just x plus 1 minus 1, and we end up with x. Now, for them to truly be inverse functions, it has to work both ways. So if we find f inverse of f of x, it also has to end up equaling x. So that means that we're going to take f's equation, which is x cubed minus 1, and substitute it in for x in f inverse's equation. So that's going to give us the cube root of x cubed minus 1 plus 1, which is the cube root of x cubed, and the cube root of x cubed is x. So we have indeed found the inverse function. The inverse function of f of x equals x cubed minus 1 is the cube root of x plus 1.